Evaluating expressions and also writing expressions is a really important skill that you would keep using throughout any sort of math class that you would take. So starting in just these pretty straightforward evaluating expressions of just 3x minus y, negative 4x over 2y, where you're just evaluating one spot. This just continues to build as you go through your math career. So evaluating expressions, in the first couple examples here, we want to evaluate the expressions when x is equal to 2, y is equal to 3, z is equal to 6. So what you want to do is you want to take each x, y, and z, you plug it into the expression, replacing its variable with that number. So on the first one, number 11, 3x minus y, I have x equals to 2, and it says 3x. 3x means 3 times x. So this is going to be 3 times 2 minus the y value of 3. I'm replacing x with 2, and I'm replacing the y value with 3. Now this expression becomes 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is 3. On number 12, negative 4x over 2y, we have negative 4 times the x value of 2 over 2 times the y value of 3. So I'm just evaluating each variable with what it's equal to. We're saying x is equal to 2, y is equal to 3, so I'm replacing x and y with 2 and 3. On the top, I have a fraction bar now. So order of operations, just deal with the top, deal with the bottom. Negative 4 times 2 is negative 8. 2 times 3 is 6. Doesn't divide cleanly, but we can simplify that down because 2 goes into 8 4 times, 2 goes into 6 3 times. So you get the fraction negative 4 over 3. And then 13, kind of didn't space this out very well. Let's take a look at 13. So 13, we have x squared minus y to the third plus z squared. So let's be careful here. X squared, what is x? X is equal to 2. So 2 squared minus y to the third. What is y? Y is equal to 3. That's raised to the third power. Plus z squared. Z is 6, so that is 6 to the second power. Just evaluate all of the exponents. So parentheses and exponents are kind of intertwined here. The parentheses right now are representing taking a value to an exponent. So 2 squared, 3 to the third, 6 squared. 2 to the second power is 2 times 2, which is 4. Minus 3 to the third power is 3 times 3 times 3. The exponent tells us how many times we're multiplying a number together. So 3 times 3 is 9, times 3 is 27. Plus 6 squared is 6 times 6, which is 36. Now it's just adding and subtracting across. So we just do 4 minus 27, and then we'd add 36, so plus 36, which is 13. So then there's our answer. (14) y squared minus 3x minus 4z. So y squared is 3 squared, same discussion as we had in the last one, minus 3 times the x value of 2. Yeah, but I looked at the wrong value. Minus 4 times the z value of 6. So we have a lot happening here. I have exponents, and then I also have parentheses serving as multiplication. So first I want to just take care of that exponent of 9. So I'm going to do 3 squared, which is 9. And then we have minus 3 times 2, minus 4 times 6. And I probably could have just did a couple steps in one, but that's okay. 9 minus 3 times 2 is 6. Minus 4 times 6 is 24. Now, another addition subtraction problem going across. 9 minus 6 is 3. 3 minus 24 is 24 minus 3, which is 21. Bigger number was negative, so negative 21. There's our answer. So those examples weren't the craziest expressions to evaluate, but just starting off, just understanding the process of evaluating an expression, these are pretty good examples because we have multiplication, we have exponents, we have division, we have everything kind of being thrown at us in more of a simpler way of just making sure we understand how to evaluate expressions. What we can do with this, like why are we evaluating expressions? What does this actually do for us? Some applications to this, I guess, if you want to call them applications, but determining whether a value is a solution to an equation. So we have this equation, 2x plus 6 equals 4x, and we want to know if I take 3, so if I set x equal to 3, is this a solution? Meaning, does it make it a true statement? Do I get a true statement? Do I get 5 equals 5 or 10 equals 10? Or do I get something like 9 equals 12, where that's not a true statement? What happens when I evaluate 3? Well, let's check. So I'm going to replace x with 3 wherever I see an x. So 2 times 3 plus 6 equals 4 times 3. 2 times 3 is 6 plus 6 equals 4 times 3 is 12. So I just did 2 times 3 is 6. I did 4 times 3 is 12. Then on the left side, I have 6 plus 6, which is 12. 12 equals 12. Yes, that is a true statement. So then we would say, yes, 3 is a solution of that equation of 2x plus 6 equals 4x. What about 16? Determine whether 4 is a solution to that. So same thing. We're going to replace any x value with 4. So 3 times 4 minus 5 equals the x value of 4 plus 2. 3 times 4 is 12 minus 5 equals 4 plus 2 is 6. 12 minus 5 is 7. 7 equals 6. No, it does not. So no, x equals 4 is not a solution. Writing algebraic expressions. This is a really, really tough skill for a lot of students, of being able to translate from a sentence like this and being able to put it down into numbers. And unfortunately, it's a really, really important skill to make sure you know how to do. If whatever math class you're going to take, you got to know how to be able to translate. So the first one, the sum of a number and 4. We're just trying to write algebraic expressions. So the sum of a number and 4. Sum means addition. So we want the sum of a number and 4. That means a number. We don't know the number. So x plus 4. Sum of a number and 4 could be also 4 plus x. Doesn't matter there with addition. X plus 4, 4 plus x. 18, the product. Product means multiplication. So the product of 5 and a number. So that means we want to multiply 5 times x. And yes, you could technically write this as x times 5, but we would generally write it as 5x, not x times 5. Twice a number. Twice a number. So twice means doubling something. Some number, we don't know the number, so we can call that x. You can use any variable, 2x, 2y, 2z, doesn't matter. Just going to use x though. Number 20, 5 times a number plus 2. So 5 times is multiplication. So 5 times a number plus means addition. So 5 times a number plus 2. Number 21, 11 decreased by a number. 11 decreased by a number. And number 22, a number decreased by 11. So I made these problems specifically for the reasons of when you look at something like 11 decreased by a number, you might either think x minus 11 or 11 minus x. Same thing over here, a number decreased by 11, because decreased means subtraction. Where you might think, is it x minus 11 or 11 minus x? And notice the order of how we wrote this. It is important. With subtraction, the order that you subtract is very important, because 3 minus 2 is not the same as 2 minus 3. Those are two different answers. So we have to really make sure we understand. It says 11 decreased by a number. If you're ever in a situation where you're like, well, I don't know if it's x minus 11 or 11 minus x, think of a number. Just, okay, well, if I decrease 11 by 2, what happens? If I take 11 and I decrease it by 2, I get to 9. How do I get from 11 and taking away 2 and 9? I have to do 11 minus 2, 11 minus x. So the answer here would be 11 minus x. 11 decreased by a number. If x is equal to 2 and I'm decreasing 11 by 2, I would get 9. How do I do that? 11 minus 2. Over here, a number decreased by 11. If I have a number, let's say it's 20, and I'm decreasing it by 11. What am I doing? I'm doing 20 minus 11. So that would be x minus 11 there. And then 23 and 24, we are kind of translating these with either an equal sign, or in this case on 23, it says not equal to 20. So let's see how we translate this. 5 times a number added to 12 is not equal to 20. 5 times a number added to 12, so plus 12, we could do 12 plus 5x also, is not, that means not equal to, not equal is the equal sign with the slash there, not equal to 20. And then last one, 4 subtracted from a number is 7. So be careful. Don't just read this and say 4 subtracted from a number like that. That's not correct. It says 4 subtracted from a number. We're taking 4 away from a number. So that's got to be x minus 4, not 4 minus x, because we want to take 4 away. 4 subtracted from a number is equal to 7. So a lot of big, important ideas and concepts here in this video of evaluating expressions all the way down to translating algebraic expressions, which is something that might take just a lot of practice.